Welcome back. Today we are cracking the code on your exams, and honestly, this one is an absolute game changer. I want you to imagine you're sitting in the exam hall. The clock is ticking. You flip the page, and there it is, a massive, high-mark question about the sun as a star. Now look at this comparison we've pulled up. On the left side, we have Alex's exam paper. On the right, we have Sam's. We are looking at a real Cambridge Physics past paper question. We're specifically focusing on syllabus code 0625 here, but listen, whether you are taking 0651, 0652, 5054, or 9702, this exact strategy applies to you. The question is asking for a detailed description of the energy processes within the sun. Now look at Alex's answer on the left. It is literally overflowing with raw physics facts. I mean, Alex knows their stuff, but there is zero analytical structure. It's just a total brain dump onto the page, and because of that, it is covered in red pen marks from the examiner. Now let's look at Sam's answer on the right. Sam completely panicked, rushed the response, totally missed the specific command word requirements, and just failed to link any of the facts together. Again, a sea of red pen. Guys, the difference between getting a B and scoring that A star in physics almost always comes down to this exact scenario. It's not just about memorizing the textbook. It's about how well you understand the core material and, more importantly, how effectively you align that knowledge with the examiner's mindset. You literally need to find the back door into every single question. You have to work smarter, not harder. Okay, let's dive into this. Here's our game plan for today's explainer. First, we'll lock down the core principles of the sun. Second, we'll introduce you to the procedural framework. Third, we're going to master the deconstruct, solve, and evaluate method. And finally, we'll go through the top examiner warnings so you don't fall into the same traps everyone else does. All right, section 1, core principles of the sun. Let's build our foundation.
Take a really close look at this specific definition. The sun, a medium-sized star consisting mostly of hydrogen and helium. Now, this might seem incredibly basic, but this is precisely word for word how examiners expect to see it written to award those basic knowledge and understanding marks. Notice the specific qualifiers they use here. It is a medium-sized star. It's not large, it's not massive, it's definitely not a supergiant. In the heat of the exam, it is so tempting to call the sun massive because, well, to us it is. But calling it a massive star is a very common factual error that will instantly lose you a mark. Furthermore, you absolutely must state its composition, mostly hydrogen and helium. You can't just say gases. These aren't just random trivia facts. They are the exact syllabus requirements you are expected to recall on demand. When a prompt asks you to describe the nature of our sun, this sentence right here is your perfectly crafted, bulletproof opening statement. It's efficient, it's accurate, and it is exactly what the mark scheme is practically begging for.
Now, let's talk about energy output. We all know the sun radiates immense amounts of energy across the entire electromagnetic spectrum, right? But the syllabus explicitly requires you to know the primary forms. This breakdown brilliantly illustrates the 3 specific forms of radiation the sun emits most prominently: infrared, visible light, and ultraviolet. Let's unpack exactly why examiners care about these 3 specifically. Infrared is the thermal radiation. It's literally the physical heat we feel on our skin on a sunny day. Visible light is the luminosity. It's how we actually see the sun. And crucially, it's what plants use to photosynthesize. And then we have ultraviolet, which is the high-energy radiation that gives you sunburns and constantly interacts with our Earth's ozone layer. So in an exam context, if they ask you how energy travels from the sun to the Earth through the vacuum of space, you absolutely must list these 3 specific components of the electromagnetic spectrum. A lot of students just write down heat and light. Don't do that. Use the proper, rigorous scientific terminology we're looking at right now. So that brings us to the actual engine of the sun. What on earth powers this massive, medium-sized sphere of gas? It is powered by nuclear fusion. I really want to emphasize that word, nuclear fusion. Do not mix this up with fission. Fission is what happens down here on Earth in our nuclear power plants, where we take heavy, unstable atoms and split them apart. The sun does the exact opposite of that. Because of the truly mind-boggling gravitational pressure and temperature at its core, it physically forces lighter atomic nuclei together. Specifically, it converts hydrogen into helium. This fusion process is what releases the colossal amount of energy that eventually radiates out to us as that infrared, visible, and ultraviolet light. Locking in this fundamental conceptual mark is totally non-negotiable. If you panic and write burning or combustion instead of nuclear fusion, the examiner will literally just stop reading and stop awarding marks for that section. The sun does not burn, it fuses. Write that down. Okay, so we've got the core facts down, right? Medium-sized star, hydrogen and helium, infrared, visible, ultraviolet, nuclear fusion. It honestly seems pretty straightforward. But here is the million-dollar question, the whole reason we're doing this explainer. Why do students find applying this terminology so incredibly hard? Why did Alex and Sam, who we looked at earlier, fail so spectacularly on their past papers when they definitely memorized these exact facts? Well, this brings us right to the examiner's mindset. You see, knowing the facts is simply not enough anymore. The assessment objectives for these Cambridge physics courses target distinct cognitive domains. Being able to just regurgitate knowledge and understanding is literally only the first step. The real challenge, the place where all the A-star marks are secretly hidden, lies in application and analysis. Students struggle because they have absolutely no idea how to translate a memorized textbook fact into a structured, logical argument that directly answers the specific command word in the prompt. They just list things, and that is exactly where our strategy comes into play.
Section 2, the procedural framework. This is the fun part. This is where we completely stop reading textbook facts and start engineering high-scoring exam answers through systematic, hacker-level analysis.
Check out this stark contrast here, superficial breadth versus analytical depth. This perfectly highlights the difference between your average student and your top-scoring, top-tier candidate. Average students, like our friend Alex from earlier, go for superficial breadth. They spot the word sun in a paragraph, completely ignore the rest of the question, and just confidently write down every single thing they've ever learned about the sun, hoping and praying to hit a keyword on the mark scheme. It's a shotgun approach, and I promise you, examiners absolutely hate it. It shows a complete lack of focus and logical reasoning. Top-scoring candidates, on the other hand, rely on analytical depth. They use what we call the PEAL framework. That stands for point, evidence, explanation, link. Here's how it works in a physics context. First, they make a clear, definitive point that directly answers the command word. Boom. Then, they provide evidence, for example, explicitly citing that the sun consists of hydrogen and helium. Next, they give an explanation, detailing that these specific elements undergo nuclear fusion due to high core pressure. Finally, they logically link their answer back to the specific context of the question, perhaps explaining exactly how that fusion generates the specific ultraviolet radiation the prompt was asking about. The Cambridge Assessment Framework explicitly prioritizes this kind of structured analytical depth over a messy brain dump any day of the week. Let's walk through the exact step-by-step processing sequence expected by Cambridge examiners. I want this to become your mental checklist for every single physics question you ever face. Step 1, identify key elements. What is the actual command word here? Is it state, describe, explain, or calculate? What values are they actually giving you? Step 2, apply relevant principles. So if the question is about the sun's energy, your relevant principle is the nuclear fusion of hydrogen into helium. Step 3, and this is massive, execute your analysis with clear working. This means writing down your formulas, showing your step-by-step substitutions, and structuring your sentences logically so the examiner can follow your brain. Step 4, verify your results. Does your answer actually make logical sense? Did your calculation accidentally prove that the sun is producing fission instead of fusion? If it did, you need to go back and fix it right now. And finally, step 5, present in an appropriate format. Use the correct units, the correct number of significant figures, and proper scientific notation. Memorize this sequence. It is your ultimate defense against losing marks to silly, careless errors.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, I need you to listen very closely to this critical alert directly from the principal examiner reports. Quote, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. End quote. We call this the method mark strategy, and it is arguably the single most important takeaway from this entire explainer. In Cambridge physics, your process is literally just as important as your final answer. Let's pretend you have a really complex calculation about the energy output of the sun. If you just punch numbers into your calculator, write down a final numerical answer on the line, and it happens to be wrong, you get 0 marks. Period. But if you write down the correct formula, show exactly how you substituted the mass of the hydrogen, and write out your intermediate steps, but then you make a silly, panicked calculator error at the very last second, you might still get 3 out of 4 possible marks. The examiner actively wants to award you marks for your systematic analysis and your evidence-based reasoning. So make a promise right now. Never, ever skip showing your working.
Now, securing those professional skills marks also requires strict adherence to the conventions for presenting information. The examiners are judging your communication as a scientist. This involves using proper headings, especially when you're tackling longer structured questions or practical alternative papers. It absolutely demands correct terminology. Again, using nuclear fusion instead of burning. You must use appropriate formats, ensuring your standard form is mathematically correct and not just a jumble of zeros. And finally, clear annotation. If you are drawing a diagram showing radiation paths or labeling a graph that shows hydrogen depletion over billions of years, your lines need to be sharp and your labels must be pinpoint precise. These practical applications develop the professional skills that the examiners actively look for and reward with points. Don't do all the hard physics work just to throw away easy marks on sloppy presentation. Moving into Section 3, deconstruct, solve, evaluate. This is the specific, high-level blueprint used by top-scoring candidates to tackle those really intimidating, multi-layered physics problems. Let's break down how this builds into our three-step methodology for hitting those higher-order assessment objectives. Step 1 is deconstruct. When you turn the page and face a massive, overwhelming paragraph of text about the solar spectrum, don't panic. You must break it down into logical steps. Systematically identify the given information, literally highlight the command words, and purposefully separate the distractors from the essential data. Step 2 is solve. Apply your core principles, like the conversion of hydrogen to helium we talked about, and systematically work through the logic, constantly stopping to check for reasonableness. Like I said before, if your calculation implies the sun is the size of the Earth, your answer is not reasonable. Stop and recalculate. Step 3 is evaluate. This is the holy grail. This is where the A-star lives. You must be able to make justified recommendations, compare different scientific approaches, or explain exactly why a particular theoretical model fits the evidence provided. A huge part of mastering the solve and evaluate stages involves critical data interpretation skills. So we're going to do a quick interactive workshop moment right now. Imagine I just handed you a complex data table showing the emission spectrum of the sun over different wavelengths. I'm starting a 60-second visual countdown timer in your mind right now. Ready? Go. Your first challenge is to extract information from that text and table. You need to rapidly scan it to find the peak intensity. Got it? Okay, your second challenge is to interpret relationships. You need to notice that as the wavelength decreases down into the ultraviolet range, the energy per photon actually increases. See the connection? Now, your final challenge before the 60-second clock runs out is to draw evidence-based conclusions. You need to confidently conclude that the sun's surface temperature directly correlates with the specific peak of its visible light emission. Time's up. That rapid three-step data scan is exactly what you need to be practicing. It is how you seamlessly integrate raw data into your Peel paragraphs without wasting precious exam time. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @aceexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we've made it to Section 4, Top Examiner Warnings. We're going to shine a massive spotlight on the top mistakes spotted over and over and over again in the principal examiner reports. Through some really extensive research into the examiner reports for the 0625 syllabus and all the related physics codes, a very clear pattern emerges. You might think there's an endless list of unique ways to mess up, but there isn't. Instead, there are exactly 3 critical mistakes spotted over and over again. These are the 3 specific traps that definitively separate the A-stars from the Bs and the Cs. If you can identify and eliminate these 3 errors from your exam execution, your mark potential is going to absolutely skyrocket. So, let's break down these top 3 mistakes. Number 1, using the wrong approach for the context. This is the absolute classic trap. A student sees the word sun in question 4A and immediately starts writing a whole paragraph about gravitational fields. But if they had actually read the command word, they'd realize the specific context of the question was about the electromagnetic spectrum. They just needed to list infrared, visible, and ultraviolet radiation. 0 marks. Number 2, forgetting to check format and presentation. This loops right back to our method marks conversation. Students feel the time pressure, they rush, they don't show clear working, they forget to write down their units, or they use non-scientific terminology like the sun burns gas. That is a fatal, easily avoidable flaw. Number 3, answers are not specific to the context given. Let's do another quick interactive challenge right now. I'm going to read a sentence, you find the flaw. Ready? The sun generates energy by converting hydrogen to helium, releasing heat which travels to Earth. What's wrong with that? The flaw is a complete lack of specific context. A Cambridge examiner wants to see the terms nuclear fusion, electromagnetic radiation, and infrared. Generic, middle school answers receive generic, low marks. You must anchor your physics knowledge to the precise terminology demanded by the prompt. To truly master this exam and become a hacker, you need to elevate your thinking to the highest possible tier of the assessment framework. Top candidates don't just recite facts. They question assumptions, they consider different perspectives, and they justify their decisions. This is what higher order evaluation actually looks like when you read a top-tier answer.
If a question presents a hypothetical tricky scenario about a star's life cycle, an A-star student doesn't just state what happens. They use the Peel framework to justify exactly why a star of medium size, composed mostly of hydrogen and helium, will follow one specific evolutionary path, contrasting it logically with the path of a supermassive star. They provide rock-solid evidence-based reasoning. They decode the command words flawlessly. When you sit down to do your speed writing practice, where you try to draft one perfect Peel paragraph in 30 seconds flat, this deeply evaluative, critical mindset is exactly what you are aiming to build. Look at how far we've come. We've covered the core physics of the sun, we've broken down the Peel framework, we've unlocked the vital importance of method marks, we've mastered the deconstruct, solve, evaluate blueprint, and we've navigated the top 3 examiner warnings. You literally now have the complete cheat sheet to hack the Cambridge physics exam. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.